So, private liquid waste. So, septic tank systems. For septic tank systems, homeowners are responsible for maintaining a septic system. If systems are properly designed and maintained, they can last a really long time. Malfunctioning systems can potentially contaminate groundwater, which is a water source, and that is a public health concern. So, ways to protect your system are to regularly inspect your tank and pump your tank as often as necessary. It's usually 3 to 5 years it should be pumped. Use water efficiently so you don't overflow your soils or saturate it, which will prevent treatment. Avoiding pouring hazardous household chemicals down the drain, which will affect anaerobic bacteria used for digestion in septic tanks. Caring for your drain field or the leaching bed. That's the soils that do the treatment at the end. So how do private liquid waste management systems work? Well, mainly there are 4 components. The pipe from the home, the septic tank, the drainage field, so the distribution from the septic tank to the leaching bed, and then the soil. Aerobic digestion occurs in the soil before it eventually reaches the groundwater. So, the pipe from the home. All of the household wastewater exits your house through a pipe that goes to the septic tank. The input is a T-pipe, which prevents wastewater from coming back into the house. And the output T-pipe is usually lower so that wastewater flows out first. In the case of sewage backups, water will build up enough to flow backwards into the higher input T-pipe that'll lead back into the house. So once water enters a septic system or a septic tank, septic tanks are usually watertight, concrete, fiberglass, or polyethylene tanks that are buried. The first compartment where water is piped in, heavy solids will settle to the bottom as sludge and lighter materials will float up as scum. In here, organic materials will break down through anaerobic digestion. Next, effluent water flows into a second tank where finer materials will settle down to the bottom and organic material will break down through anaerobic digestion again. Before leaving a septic tank, effluent will go through an effluent filter that traps remaining organic matter in wastewater. And then next it'll go into the drain field. So septic tanks hold wastewater long enough to allow solids to settle and scum to form to the top. It'll also partially decompose solid materials. Water in compartments are, again, because the T-shaped piping, the input is higher than the output pipe. Wastewater will flow out before it flows back into the home. And because the pipe is lower, it'll prevent scum from going into the next tank and prevent sludge from flowing to the next tank. Screens are recommended to prevent solids from going into the drain field. So that's the effluent filter. Newer tanks tend to have risers and lids for easy location, inspection, and pumping. To prevent sludge and scum buildup, you need to periodically pump your tank, again, every 3 to 5 years. And regular inspection and pumping are important for keeping the system working. Older septic tanks are harder to find on properties. Generally, manhole covers are indicators of septic tanks. Next, the drain field. Wastewater exits the septic tank and is discharged into a drain field for soil treatment. When new water comes in, wastewater or effluent enters the drain field. If the drain field is overloaded, it'll flood and can cause sewage to flow into the ground surface or create backups in plumbing fixtures. This will prevent wastewater treatment. Wastewater flows into the drain field, which is, soil. And soil is the final treatment method for wastewater in septic systems. So septic waters flow into the drain field and it percolates into the soil. Soil is necessary for successful wastewater treatment. It treats water by filtering out particles, removing chemicals and nutrients, and act as a site for destroying pathogens. Soil is ionically charged and will oxidize water and destroy pathogens. Soils are negatively charged and hold positively charged chemicals and viruses in place. Soils have minerals that bind with pollutants. Soils can also contain aerobic microbes, which can help treat water. Some factors in wastewater treatment include soil characteristics, so what types of soils they are and what sort of minerals soils have, and the biological activity of soil. So what kind of microbes does the soil contain? It's important that soil removes nitrogen and phosphorus. Nitrogen is usually removed through the uptake of plants through denitrification. Nitrogen is removed through biological means. Bacteria or plants will convert ammonia into nitrate. When nitrate is in a zone with no oxygen, anaerobic bacteria will convert it as nitrogen gas. Sandy soils don't have much organic matter, and denitrification rarely occurs. Once nitrate is in the groundwater, it's hard to mitigate, so it's important to remove nitrogen from wastewater in septic systems. The best way to do that really is to not introduce it at all. Phosphate is usually found in detergents and human wastes, can be removed by combining it with minerals such as calcium, manganese, and iron. Clay is better at binding with phosphates. If leaching beds are set up with proper distances from surface water, the movement of phosphate to groundwater should be minimal. And phosphorus, once it's in surface water, can lead to eutrophication and kill off a lot of aquatic life by decreasing the dissolved oxygen in the water. Soil biological activity. So soil has a complex community of microbes which feed on organic matter in wastewater. Aerobic bacteria are better at breaking down materials in wastewater than anaerobic bacteria. If soils are saturated, meaning filled with water, then no oxygen is present in the soil, and anaerobic bacteria will be more predominant than aerobic bacteria, and little treatment will occur. It's important that drain fields are not waterlogged or saturated with water. Lastly, soil is a hostile environment for bacteria due to temperature, moisture, and soil predators. Viruses are usually not filtered out. They're trapped by negatively charged soil. Fungi in soil can act as antibiotics and inhibit and kill bacteria. There are also alternative systems. Proper soil treatment isn't always available, and these alternative systems tend to use sand, peat, or plastics instead of soil. They can also use wetlands, lagoons, aerators, or disinfection devices. Other systems use float switches and pumps and other electrical or mechanical mechanisms. These mechanisms need to be regularly inspected. So important things for maintaining healthy septic systems. It's important to pump systems of sludge and scum every 3 to 5 years. We also want to ensure surface water is drained away from the field, again, to prevent saturation of soils that are used for treatment. Filling systems are expensive to repair or replace. Having it regularly inspected will help prolong the life of the system. Well-maintained systems will prevent contamination of water sources. Nitrogen, phosphorus, and disease-causing bacteria are pollutants of concern from household wastewater. Improperly treated wastewater can infect our groundwater and surface water. Some other methods of protecting our septic systems is using water-efficient appliances. Less water being used equals less water entering the septic system and less chances of failure. So if we use less water, the retention time or the time wastewaters in septic tanks and anaerobic digestion can occur will be longer, and longer retention times means more anaerobic treatment. Also, pouring household chemicals, gasoline, oils, pesticides can also affect treatment. Things like bleach can kill anaerobic bacteria in our system and make our treatment less probable. And when treatment's not efficient enough, it can contaminate groundwater, which can produce adverse water results in water samples. For drainage fields, it's important to plant only grass, as roots from trees or other plants can damage drain fields. It's also important not to compact the soil in drain fields, and compaction can be done by driving over the system. And again, it's important to drain surface water away from drainage fields. So some symptoms of a failed system can include pooling water or muddy soil around septic systems or basements, toilet backups, or toilets, sinks, or laundry machines that produce an odor, or strips of bright green grass over the drainage field. Well water test results that are adverse could also mean the septic system is not treating water properly and has contaminated groundwater. So some causes of failure. So pouring toxic household materials such as paint solvents down the drain can kill bacteria needed for digestion and also contaminate the groundwater. Pouring household cleaners can also kill bacteria needed for digestion and contaminate groundwater. So emptying our hot tubs or pools into the septic system, this can really decrease the retention time in our septic systems and saturate the soil, leading to inefficient treatment. Water purification systems like water softeners tend to pump water into the septic systems when water isn't being used. And again, more water in the system leads to decreased retention time, which can saturate the soils further. Next, garbage disposals can increase the amount of grease and solids put into the septic systems. It's better to avoid garbage disposals because more scum and sludge can take up volume in septic tanks, reducing retention time and increase the chances of scum and sludge clogging components of the system, leading to sewage backup. Leaking plumbing fixtures like faucets or showers, again, can lead to excess water in the system, less retention time, and reduce the life of the drain field. Events such as excess rain or water can again saturate soil and damage drain fields. So, due to the constant flow of water out into the drain fields, this should be sufficient enough in preventing the freezing of septic systems. So effluent filters are a device installed in an outlet baffle of a septic tank that assists the removal of solids from a wastewater system before it enters the drainage field. It's designed to protect the drain field and allow for cleaner effluent to exit the tank. Things to consider when building a septic system. We want to consider the location of a well relative to a septic system. Because septic systems leach water into the ground, a failure in the septic system could potentially infect our groundwaters, and usually rural homes have septic systems and ground well waters. Adverse events can lead to septic failures, which can lead to infected groundwater systems, which can lead to human infection through drinking waters. Again, along the lines with protecting the groundwater, we got to consider the size of the property and property lines. We also don't want to infect neighboring groundwater systems as well, or affect their homes. Topography, slopes of lands. So it's important to consider, we don't want our septic systems to be downstream or upstream rather. We don't want it to flow into surface water. So if our house is on a hill and down the hill there's a stream or river, we don't want to build a system that will potentially infect those waters, or even other people's groundwater systems downstream. We also want to consider the height of the groundwater table, again, because wastewater is leached into the soil. If there's a high groundwater table, the potential for infecting groundwater, drinking water sources will affect, it can lead to contaminated drinking waters. And the next is type of soils on the property. Septic systems use soil as the final treatment by leaching the wastewater into the soil. If soils have a quick percolation time, or rather a tea time, this can potentially not treat water effectively. Alternatively, if we have a high, soils high in clay, percolation time is increased, and we can end up with pooling water and oversaturated soils that can't support aerobic bacteria for digestion. Lastly, the location of trees, roots of plants can damage septic lines and affect treatment of water. So next, I'll talk a little bit about some requirements from the Environmental Protection Act, which is under the Ministry of Environment, Conservation and Parks, so MOECP. They're in charge of enforcing these laws or rules. So specifically Regulation 358, sewage systems. So when building a sewage system, it's important that wells, springs, and potable water sources are 30 meters away. Wells with tight water casings are 15 meters away. Structures are 5 meters away. And the systems are 3 meters away from property lines. And again, spring, lakes, rivers not used for potable water systems are 15 meters away. So a percolation test, or percolation time, or tea time, is the average time in minutes that is required for water to drop 1 centimeter during a soil percolation test. If tea time or percolation time is more than 50 minutes or less than 1 minute, you can't use it for leaching beds or drain fields. Retention time is the time septic effluents spend in a tank before flowing out onto the drain field. If a tank isn't pumped frequently, the buildup of sludge and scum can shorten the retention time, and drain fields will have a shorter life because of its increased activity. Retention time needs to be long enough to allow for proper separation in septic tanks. Too much wastewater coming through can lead to solids being leached into the drain field. And inadequate retention time can lead to clogging draining fields. And if drain fields are clogged, wastewater won't be properly treated and soil can contaminate groundwater. So, dye testing is used in septic tanks to make it easier to spot major problems without being too invasive. For example, you'll put dyes in your toilets, and if you see the dye, for example, in certain parts of your septic systems, it'll indicate that there's a leak in that part of the system. It's often used to see effluent leakage for broken pipes or incorrect installations. If it shows up on the ground, it means there's a problem. But using little or too much water or rain or snow melt can result in test failures and dye tests. And again, most septic tanks should be pumped every 3 to 5 years. When testing water, it's important to include biological, so bacteriological, so like E. coli, and nitrates and water. Again, it's important. We don't want nitrates contaminate our groundwater because nitrate becomes, in the presence of oxygen, can react and can mess with hemoglobin and block oxygen transportation in blood, which is very dangerous and can lead to suffocation in humans. And that concludes septic systems.